Okay, so this is we're talking about chapter 4, section 6. Which is really going to be special factoring. And I do want to emphasize the fact that you could work every one of these problems the way that we've been working them, but if you happen to know this trick, it just kind of makes your life a little bit easier. It's like a shortcut. So the two formulas that we really start off emphasizing are a squared plus 2ab plus b squared is equal to a plus b squared. Okay, then there's another one that says a squared minus 2ab plus b squared is equal to a minus b squared. So those are the two that we're going to, if you can recognize that the problem does this, it kind of helps you make a shortcut. Okay, so our first problem says to factor y squared plus 12y plus 36. Now, really quick, I'll go, remember we were doing this thing where we would try to think of what multiplies to 36 and adds to 12. That's the way we were doing it, and there's nothing wrong. You can continue working it that way. 6 times 6. 6 times 6 is equal to 36, and 6 plus 6 is equal to 12. So that would be our answers that went here. And we talked about that in the last two sections. And when we got those answers, we would come over here and say, well, the answers are y plus 6 times y plus 6. And you can continue working on that way if you want to, okay? All this is saying is if you have this problem, you start out with your y squared plus 12y plus 36, and you look at the last term, and you take the square root of 36. So in other words, you're trying to think of what multiplies to, what two numbers are the same that multiply to 36. So the answer would be 6 times 6. So this could be 6. Then you also look at your leading coefficient, which is the number in the front, and there's no number there, so we know it's a 1. And if you take the square root of 1, then you get 1. Okay, and if you take those two numbers, because that is going to be in these formulas, that's your A and that's your B, right? If you look at these two formulas, the first term is your A, the second term is your B. So they're saying if you can get the middle term by taking them and multiplying them by 2, so 2 times 1 times 6, which is the last term, and that gives me 12. Okay, and what I know about that is what I have, right? I have a positive 12y and I've got a 12 here. If I can really do a quick check on that, then that means I can cheat real quick and use this formula to factor it, okay? I'm going to say it again. This way would have gotten us, the way we were doing it last class would have gotten us answer 2, but these are just special cases. So I know that when I take the square root of 1 and the square root of 6, that I can just say, oh, well, that's a plus b squared, which would have gotten me my y plus 6 squared, which is the same thing as y plus 6 times y plus 6. So it's just a shortcut to get us our answer faster if we can recognize that that's what's happening. So let's hit a few more. Hit a few more of these examples so you can see, because I'm going to quit doing this okay? Because if I do that for every one, we'll be lost. So let's work another example. Let me do this. Let me try this. Okay, so this next one, we're going to factor. Nine y squared minus 30y plus 25. Now, on your homework, you know that you're in section 6. And so if you're in section 6, that means that one of these formulas is supposed to work. So you should be able to cheat on most of these problems, because that's the whole purpose of looking at this thing. So if you're in section 6, you're supposed to be able to use these formulas to get our answer. But those are the two formulas we're kind of focused on right now. So how do you know if you can use one of those formulas? Here's what you do. You take the square root, you look at your first term here, and you take the square root of 9y squared, where the square root of 9 is 3, because 3 times 3 is 9. The square root of y squared is y, because y times y is y squared. Okay, then you come to the last term, you take the square root of it. The square root of 25 is 5, because 5 times 5 is 25. Okay. Then you go, okay, I'm supposed to take a 2, because that's what's up here in these formulas, a 2 or a negative 2, either way. And I'm supposed to multiply by both of these square roots that I got. So 3y and 5. Well, 2 times 3 times 5 is 30, and then we've got our y, right? When I get that, I want to compare that to this middle term right here, and I want to say, oh, those are very close, right? One of them is just negative. Well, that means that if it's negative, I want to use this second formula because it has the negative there, right? This one has a positive 2ab, this one had the negative 2ab. So this is the formula that I want to use. And I want to go straight to this a minus b squared, because without doing that, this is the whole reason you can cheat, okay? This first thing that we found was our a. The second thing that we found was b. So I can just go straight to the answer and say, well, it's 3y, because that's my a. Then it's minus b, which is 5 squared. And just keep in mind that that's the same thing as 3y minus 5 times 3y minus 5. Okay, if we drew the x and everything like we did before, this problem would work out the same way. This is just kind of a quick shortcut. If this situation happens, you can go a little bit faster and not have to figure all that stuff out. Okay. So let's look at another one. Let's say we have 16y squared plus 56y plus 49. Okay, remember that the very first thing you want to do is see if these three terms have anything in common that you can pull out. In other words, does 16 have anything in it that 56 has in it, that 49 has in it, and they don't. And the reason I know is 49 is 7 times 7. It's prime. It's not prime, but 7 would have to go in these other ones, and I know 7 doesn't go into 16. So the first thing you want to do is see if there's anything you can factor out. Okay, in 4.6, you want to go, okay, First step, take the square root of 16y squared. Well, that is 4y, because 4 times 4 is 16, y times y is y squared. Then go to your last term and take the square root of it. So 49, square root of 49 is 7, because 7 times 7 is 49. Then to see if you're able to do the trick, you take 2 times both of these things. Okay, so I don't know why I did that, sorry. You need to do the 7. So we would put 4y and we would put 7 here. And 2 times 4 is 8. 8 times 7 is 56. And then we're going to come back and get our y that we didn't put. And you want to see, does that match this middle term? And yes, it does. And if it does, you can use the trick. So we're going to look up, both of these are pluses. So when I look up here, I want to use the one that has both of them to be plus for my formula. So I know that the answer is a plus b squared. Well, a is going to be this, b is going to be this, so 4y plus 7 squared, which is the same thing as 4y plus 7 times 4y plus 7. Okay, am I going too fast? Okay. Let's look at least a couple more of these. If I've got a squared plus 2ab plus b squared equals a plus b, these are those special cases. This one looks a little bit different. Let's do this. What if I've got 5x squared? We're trying to factor. 5x squared minus 10xy plus 5y squared. This time when I look at this, I go, oh, this has a 5 in it, that has a 5 in it, that has a 5 in it, right? So this is one of those times where the first thing you want to do is you want to factor out 5. So that means when I get ready to write my answer, whatever it is, it's going to have a 5 in front of it. Okay, that 5 is going to be in front of it. So if I take a 5 out of 5x squared, well, I just have x squared. If I take a 5 out of negative 10, well, that's going to give me negative 2, because 5 times negative 2 gives me negative 10. Still have my x and y there. If I take a 5 out of 5y squared, well, that's just going to give me y squared. Okay, so I know that my answer is going to have a 5 in front. Now I want to take, remember you're going to take this term and you're going to take the square root of x squared, which is x. If this little trick works, that should be our a. Then we go to our last term and take the square root of y squared, which is y. If this works, then that's going to be our b in our equation. And then you go, well, what is 2? You always multiply 2 times, because the middle term both have a 2 or a negative 2 in front. 2 times you plug in the x, and then you want to plug in your y, which is going to give me 2xy. And I want to look and say, oh, does that match? Yeah, it's just one of them is negative and one of them is positive, right? But I've got negative 2xy and positive 2xy, which means that I want to use this formula that has the negative there, right? So I can go straight to my answer. My answer is supposed to be the one that's a minus b squared. So my a was x, my b is y. So I would say x minus y. We're squaring it, so we would have two of those. You could shorten it and make it x minus y squared like that. Same thing. Questions? Okay, let's look at another one of these. Because they can get a little bit tricky, so this one's a little bit more complicated. Let me. Okay, so this next problem, we have 2y to the fifth plus 48y to the fourth plus 288y to the third, okay? So remember that the first step is, can I factor anything out? That's what you should be asking anytime you have to factor something. Can I factor something out of all these? So I'm looking at this and saying, well, the only thing I can factor out of this first term is a 2. If I just focus on my numbers, 2 and 48 and 288, but I know I can at least factor a 2 out of all that stuff. So I can take a 2 out. What's the most amount of y's I could take out? This has a y to the fifth, this has a y to the fourth, and this has a y to the third. So I could possibly take out a y to the third because they all have at least a y to the third in them. So I can take out a y to the third. That means that when I get ready to write my answer, I need to have a 2y to the third in front of whatever's there, right? Has to happen because I'm pulling that out. That's part of my answer. So if I take a 2 out of 2, I don't have any numbers there, but if I take a y to the third out of y to the fifth, remember that you would do 5 minus 3, so you would just have a y squared right here. 5 minus 3 would leave you with a y squared. I take a 2 out of 48, take a 2 out of 48. Well, 48 divided by 2 is 24. And if I take a y to the third out of y to the fourth, if I take a y to the third out of y to the fourth, I would do 4 minus 3. Well, that's just y to the first, right? 4 minus 3 is just y to the first. 288. If I take a 2 out of that, 288 divided by 2 is 144. And if I take a y to the third out of y to the third, I won't have any y's there, right? Done with that. So the first step is always see if there's anything you can factor out. Now we're going to look at these and go, okay, let's look at this first term. If I take the square root of y squared, I would get y. That would be, this is what a would be if this works. If I take my last term and take the square root of 144, I'm going to get 12. And this is what b is. Okay, then I want to see, well, does my little trick work? Can I use my formula? I'm going to say, well, what is 2 times a, which is y, times whatever we got over here, which was 12. Well, 2 times 12 is 24, and then we've got our y. And you want to compare that 24y to what you have right here, and they are the same. In fact, they're both plus. So we know we want to use on this one, because they're both the same, we want to use our top formula because it has the positive 2ab and not the negative 2ab. So remember that we said a, so we know that this one right here, this a plus b squared is going to work. Well, we said a was y here. We said b is 12. We just fill it in. Because our a is y, b is 12, and that formula is the one that works. Okay. Do you want to see, does anybody want to see one more of those type special formula? Okay. We have one other type of special formula that we're going to talk about, and this one's easier to me. This is called the difference of squares. Okay, and then in the difference of squares, it says that if you've got a squared minus b squared, that is equal to a plus b times a minus b. So this one is, I feel like, really super easy to grasp. This is one of those cheats I would try to figure out. Remember that if we were going to work this the way we did this the other day, this one is kind of missing a middle term. We've got x squared minus 4, and usually what you would see is you would have an x squared, and then you'd have some number right here that's multiplied times x, and then you would have your minus 4. Well, in this case, the sum number that we're multiplying by x just ends up being 0 because we don't have anything multiplied by x. So if we were going to work this the way we were doing it the other day, we would say, well, what multiplies to 4? What multiplies to negative 4 and adds to the middle term, which is 0. You'll kind of recall about that. So we would have to go, what multiplies to negative 4 and adds to 0? Well, negative 2 times positive 2 is negative 4. But when you add those two, you get 0. So one of them is negative 2, and the other one would be positive 2. So when we wrote our answer, we would say x minus 2 times x plus 2, and that's where they're coming up with this. One of them's positive and one of them's negative, okay? So this is called the difference of squares, and this is one that I would say, if the other one you might not take time to memorize, that's the way that works, because you could just do it the way we've been doing it. This one saves you so much time if you recognize it that you want to do it, okay? So how am I recognizing that? So here's another problem that we've got like this. Let's say if it said factor y squared minus 64, what you're going to say is, well, first off, it's the difference because it has a subtraction sign. So if it doesn't have a subtraction sign, you can't work it this way. It has to be a subtraction. Then you want to say, well, is the square root of y squared, if I take the square root of y squared, does it come out perfect? Yeah, it's just y. It has no decimals or anything. Then you want to go, well, what's the square root of the last term? Square root of 64 is 8. 8 comes out perfect too. That's why it's called the difference of squares, because we can take the square root and they come out perfect. And we know that it's y minus 8 times y plus 8 after you do that. You're done, because that middle term is going to cancel out and be 0. You can switch it and do y plus 8 times y minus 8. That's the same difference. Doesn't matter which one you put in the front or the back. Difference of squares. Okay. Okay, let's do, what if I have So if we had I'm just going to put this up here to remind us. If we have this situation, then we can do a plus b times a minus b. So I've got a problem that says 49 t squared minus 9r squared. Well, the first thing is that it has a minus, right? So we want to factor that. If it has a minus there, I might be able to use this difference of squares. But what I need to check is, does the square root of 49t squared come out even? In other words, we don't have any decimals there or anything. Well, the square root of 49 squared is, 49t squared is 7t, because 7 times 7 is 49, and t times t is t squared. Well, this one, the square root of 9r squared has to come out even too. The square root of 9 is 3, because 3 times 3 is 9. And the square root of r squared, well, that's r, because r times r is r squared. So once again, we have the difference because we got a subtraction of squares. Whatever you get here is going to be your a. Whatever you get here is your b. So we can go straight to the answer. It's going to be 7t plus 3r. I almost wrote b instead. And the other one would be 7t minus 3r. If you wrote that in the reverse order, 7t minus 3r first and 7t plus 3r in the back, that's fine, same difference. Okay, we've got factor 16 x to the 8th minus 64 x to the 4th y squared. Turned it up a notch, right? We do have the difference because we're subtracting. We've just got two terms, so we might be able to use this, but the first thing you need to do, is there anything that 16 and 64 have in common? I know 2 goes into both of them. I know 4 goes, 16 even goes, right? So we could pull out a 16 from both of these. And I'm also noticing that I've got x's in both of these two terms. And so I could actually pull out x to the 4th because they both have at least, this one has 8 x's and this one has 4 x's. So I could pull out an x to the 4th out of both of those. So that's the first thing you always want to do, is get rid of that. Whenever you do that, you know that your answer is going to automatically have that 16x to the 4th in it. We don't know what else it's going to have, but it's at least going to have that. Okay, now we want to do what we said. So if we take out a 16 out of 16, we would just be 1. And if we take an x to the 4th out of x to the 8, 8 minus 4, well, we'd still have x to the 4th. Okay, if I take a 16 out of 64, and I just brought my minus sign down, but 64 divided by 16 is 4. If I take an x to the 4th out of x to the 4th, I wouldn't have any x's there, but I still have this y squared. So now we want to kind of look at this and go, can I take the square root of x to the 4th and it come out even? Well, it's x squared because x squared times x squared is x to the 4th, right? What about this? Take the square root of 4y squared. Well, the square root of 4, 2. The square root of y squared, y, right? So we could do that. So this is our A, this is our B. So x squared minus 2y squared. No. Almost didn't catch myself on that one. So x squared minus 2y, and then we have to do the other side of that, sorry, which would be x squared plus 2y. Okay. That was probably the most difficult of all those problems that are like this. Let's do one more of these just because I want to make sure you've seen all these examples. Okay. So the last one of these, let's do factor 25 t squared minus 16r to the, well, this one's actually not that bad, but we can do it. We can, I mean, you can recognize this pretty quickly that this is a difference of squares. I can't factor anything out of 25 and 16, and this is a t and this is an r, so can't do that. So I can take the square root. I know it's the difference, it has the minus sign. The square root of 25t squared is 25t. The square root of 16r squared is 4r. So this would be my A, this is my B. So we have, this should just be 5. The square root of 25, sorry about that, is just 5t. And so we would want to 5t minus 4r, 5t plus 4r would be the answer there. Okay. So we are moving on to 4.8. 4.8 is kind of a shorter section, and then we're done with chapter 4. We're going to be ready to review on the next class. So this is 4.8. We're basically talking about some applications of these polynomial equations and functions. So the first problem says the factor, kind of bringing everything together a little bit. X squared minus 8x is equal to 0. They want us to factor this. Well, we talked about the first thing you want to do is you want to, if there's anything that you can pull out of both terms, that's what you want to do. And I'm seeing an x in both of these terms. So I would take an x out of the x squared, and I would also take an x out of this 8 minus 8x. If I take an x out of x squared, that's just going to give me x. If I take an x out of this minus 8x, I still have minus 8. Okay, and this is going to come in handy later when they ask us to solve this, but for right now, we're not having to solve, we're just factoring. So on this problem, if we were to write it in a way that looked a little bit more familiar, we would say x minus 0 times x minus 8. That means the same thing. I just don't have to write the minus 0 part, but I can pull that x out of both of those terms. Okay, so when you see that, that's what you want to do. We've got factor 11y plus 4y squared equals 3. Well, this is weird because usually we don't have anything over here, right? It's usually just always equals 0 every single time. So we need to make it equal to 0. In order to do this one, we're going to need to subtract 3 from both sides. So I'd have 11y plus 4y squared minus 3 is equal to 0. Well, another thing that I'm kind of noticing about this one is in order for me to factor it, it doesn't look like that usually. We usually have a y squared in the front, right? Not in the back or in the middle. So I'm probably going to want to rearrange this a little bit so that I have 4y squared, my positive 4y squared, I would put that in the front. We would put it in descending order, which we had been working on doing chapter 4. But you usually put your highest power exponent and then your y to the first and then your constant to solve that. Okay, and I'm not going to go to the graphing calculator on these while I'm teaching, but if you want to work it the way that I showed you to do with that, that's fine. But we would still need to set it up. So we would say, okay, we need to do 4 times -3, which is -12. That goes on the top. We would be looking for something that multiplies to -12 and adds to 11. So 2 numbers that multiply to -12 but add to 11. Well, you could come up with lots of things that multiply to -12, but I do know that 12 times -1 is -12. And if I do 12 plus -1, I get 11. So that's the combination that works. So even when we go to the graphing calculator, the trick that we did, it would give us the 12 and the -1 part. We would know that. But because we had a number in the front, right, which is the 4, this is kind of review from what we did last time, but because we have the 4 in the front, we would need to divide both things by 4. And we would want to reduce those fractions. So 12 divided by 4 would get me 3. And then -1/4, well, that's already reduced. So my answers, I would use the 3 and the -1/4 to write my answer. And remember, we would put the number on the bottom and front. So we would say 4y minus 1. And so on this one, we would want to write it as a fraction. So we could say 1y plus 3 okay? So main thing here is you wanted to get it equal to 0. So you move the 0, then you get it in order of what you had, okay? Questions about that? And then you just solve it the way we've been solving it. Okay, so let's look at some more of these. What if it says to factor 18y to the 9th minus 27y to the 8th? Hoping that you're looking at the 18 and the 27 and you're going, ooh, I think 18 and 27 have something in common, right? 9 goes into both 18 and 27, so I can take a 9 out of that. Can I take any y's out of both groups? They both have at least a y to the 8th in them, so I could pull out a y to the 8th. Okay, 18 divided by 9, leave me with 2. If I take 8 y's out of y to the 9th, I only have 1 y left. -27 or -27 divided by 9 would give me -3 or -3. And I already pulled all the y to the 8's out. So if I took y to the 8th out of this, I wouldn't have any y's left. And I can't really factor 2y minus 3. That one's done. Okay, so these look just a little bit different, but there's an example of that one. Factor 12x squared minus 48x plus 45. The first thing I want to do is say, we'll do this 12 and 48 and 45 have a number that's in common that I can pull out of all of those. I'm thinking 3. So 4 would go into these two, but it won't go into this one. So I think 3 is going to be our biggest number that's going to come out. I can't pull out any x's because this last term doesn't have any x's in it. So I'm going to try to take a 3 out of all those. 12 divided by 3 is 4. Negative 48 divided by 3 is negative 16. 45 divided by 3 is 15. Okay, now I'm at the part where, okay, I want to factor the rest of this. So I need to, I know my answer is going to look something like this. But I'm just focused on this middle part right now. So I want to say, well, 4 times 15, which is 60. So I'm looking for something that multiplies to 60, but adds to negative 16. And this is where we go to the calculator and we do that trick, right? 60 divided by x and 60 divided by x plus x in both of them. But the calculator would give us that combination. I'm thinking of it in my head, but of the things that multiply to 60, negative 6 times negative 10 multiplies to 60. But when I add negative 6 plus negative 10, I get negative 16, which is what we needed to have. So those would be my things that go right here. Negative 6 and negative 10. Because we have this number in the front, I'm not done. I have to divide by 4 and reduce those fractions. Negative 6 over 4, well, that's going to be the same as negative 3/2 because I can divide the top and the bottom by 2. Same thing for negative 10 over 4. 2 will go into both of those, so I would get negative 5 over 2. So we're going to use these two things to write our answer. Okay, and remember that the number in the front goes on the bottom with the x, and your numerator goes in the back. So 2x minus 5. And it would be perfectly fine if you had switched those 2x minus 5 times 2x minus 3, same answer, right? Okay. Am I good? Or y'all, do I need to slow down? Let's factor one more of these. And then we're going to solve. The solving part is probably the easy part, but it says to factor 10x to the second minus 40x minus 120. First thing I'm noticing is I can take a number out of each one. I can take a number out of 10 and 40 and 120 because they all have a 10 in them. So that's the first thing I'm going to do. I'm going to divide all these numbers by 10. I can't take an x out because this last number doesn't have an x, but I can at least get that 10 removed from all of them. So I divided 10 by 10 and got 1. Negative 40 divided by 10 and got negative 4. Negative 120 by 10 and got negative 12. Okay. We know that our finished product is going to have the 10 in the front. But we need to figure out, well, what multiplies by to negative 12? Now this time, whenever I did this, this is just 1x squared, so I don't have to do, I mean, you can do 1 times negative 12 is just negative 12. This one is just easier when there's a 1 in the front. So I'm looking for things that multiply to negative 12 and add to negative 4. Negative 6 times 2, negative 12, negative 6 plus 2, negative 4. So those are my two numbers, negative 6 and 2. Because I have a 1 in the front, though, I don't have to do that division here. I can just go straight and say my answer is x minus 6, x plus 2, because the leading coefficient here was a 1, so this one wasn't as bad. Okay. Now, so there are 4 problems that we're going to solve for this, and then we're going to be done with chapter 4. But we factored a whole lot, but how do we find the answer? How do we solve this? So you're going to start by doing just what we've been doing, but if it says solve 5x squared minus 9x minus 2 equals 0, the first thing you're going to do is you got to factor it. In order to solve it, you've got to factor it. The first thing you want to do is factor. Just like we've been doing this whole time, you're going to say, well, I need to divide that. Well, first off, you look and see, does 5 and negative 9 and negative 2 have anything in common that I could factor out? But they don't. Okay, so then I know, oh, I got to do this thing where I get it down to the factored part. So I'm going to take my 5 times my negative 2. 5 times negative 2 is negative 10. So I'm looking for something that multiplies to be negative 10 and adds to be negative 9. Okay, this is where you would go to your calculator and do negative 10 divided by x and negative 10 divided by x plus x, or you could use that polyroot finder on your calculator. If you're doing it by, and there's videos posted on chapter 4 on the previous sections that say calculator help if you need to go back and look at those. But the calculator is basically doing this work that I'm doing for you. Once you get to this point, you can say, I need 2 things that multiply to be negative 10 but add to be negative 9. Well, that's negative 10 times 1. Negative 10 times 1 is negative 10, but negative 10 plus 1 is negative 9. So the calculator will help you locate those 2 numbers, the negative 10 and 1, that make this work. Then you're going to go and divide by the number in the front of your leading coefficient to finish this. And you're going to reduce those fractions. Well, negative 10 divided by 5 is negative 2. And 1/5 is already reduced. So those are the 2 things we need to deal with. Or it doesn't matter what order you write them in, but 1/5 and negative 2. You put the 5 in the front, not a 2. You put the 5 in the front with your x, or whatever your variable is, and you put the 1 in the back. Negative 2 is not written as a fraction, so you might want to write it as a fraction. The 1 would go in the front with the x, the minus 2 goes in the back, and that's supposed to be equal to 0. So we have factored it. You can't really solve it until you factored it, so now I'm going to solve. So this is something new. We've been factoring this whole chapter 4, but now we're solving. So in other words, what can we plug in for x that's going to make this statement true? 5x squared plus 9x minus 2. To solve this, which is what the poly root finder thing on your calculator does for you, you let 5x plus 1 equal 0. Then you let 1x minus 2 equal 0. So you've got two different things that you're looking for. So I just split these up and let them both equal to 0. Now I'm going to solve them, and that's going to give me the answer. So we go to the side with the x on it. We subtract 1 from both sides of the equal sign. Going to bring down our 5x here and divide by 5. So one of the answers that makes this work is negative 1/5. Okay, when I add 2 here, I would get 1x is equal to 2. We don't really have to divide by 1, but since I stuck that 1 in front, you just get x is equal to 2. These two things are my solutions. I solved it now. If I were to plug in 2 up here for x, you don't have to write this down, but if I were to plug in, so my original equation says this. Okay, instead of x's, I just put blanks for my x's. If I were to plug in what I said, one of the answers is 2. It's supposed to be 0, because that's what I was supposed to have it equal to, and it is. 5 times 2 squared minus 9 times 2 minus 2 is equal to 0. Okay, if I plug in my second option, which I also say is correct, negative 1/5 that I got down here, if I plug that one in for x, it's also going to be equal to 0. Both of them are going to work. When you solve one of these, what you're really doing is this graph right here looks like a parabola. Okay, this is just extra information right now, but this graph looks like a parabola. That's half of a U, but the fancy word for that is parabola. These places on the graph where it crosses the x-axis are the answers. Those are my answers where it crosses the x-axis. That's what, when I found this negative 1/5 and 2 on this one, this would be my negative 1/5. I know I didn't draw it to scale, and this would be my 2. They're places where it crosses the x-axis. So you can also check yourself if you graph it. Okay, and we'll be working on some more of that in a little bit, but okay. So now we're down to 3 problems. We want to solve this. 5x squared minus 20 equals 0. First thing we want to do is look and see if we have to factor it first to be able to solve it. So do 5x squared and 20 have anything in common? I think I can pull out a 5. If I take a 5 out of 5x squared, I'm left with my x squared. If I take a 5 out of 20, I'm left with minus negative 4 equals 0. This is one of our special cases. It is the difference of squares, right? Because I can take the square root of x squared and it's just x. I can take the the square root of 4 and it's just 2. So this ends up being 5 times x minus 2 times x plus 2. So I factored it. Now the second thing I need to do is solve this. You really can't do anything with this 5. You just really need to focus on when you're solving it, you can get rid of that number in the front and just figure out, well, what's x minus 2 equals 0 and what's x plus 2 equals 0. That's what you're doing when you're solving. You're setting both of these things up to be equal to 0. We're going to add 2 to both sides. and get x is 2. This one we would have to subtract 2 from both sides and get x is -2. So if I were to graph this parabola, I would have answers at -2 and +2 because that's where it would cross the x-axis. Okay? Last two problems. This one says, given that f of x is equal to x squared plus 12x plus 40, find all values of x such that f of x is equal to 8. Okay, so remember that we said f of x is just a fancy way for saying y. So what they're saying that f of x is equal to 8. So I'm going to write down my problem. F of x is equal to x squared plus 12x plus 40. But instead of f of x, they say f of x is 8. So I'm going to put an 8 here. First thing you need to remember is if this is not equal to 0, you can't work it. Okay, you need it to be equal to 0. So we need this 8 to move over to the other side of the problem. So this side is equal to 0. So I'm going to subtract 8 from both sides of my equal sign. It's the first thing I'm going to do because that's going to get me my 0 that I need this thing to be equal to. 40 take away 8 is going to get me 32. Once you've got it equal to 0, you want to factor. So we need this part of this. So we need to think of something that multiplies to 32, but adds to 12. 8 times 4, 32. 8 plus 4, 12. So those are my two numbers that need to go right here. This one doesn't have to get divided by anything because there's no number in front of the x squared. This one's one of the easy ones, remember? If it's just a 1, you can just be done and say, well, that's x plus 8 and x plus 4. Then we're ready to solve it. And to solve it, you say x plus 8 equals 0 and x plus 4 equals 0. We're going to subtract 8 from both sides, so x is -8. Going to subtract 4 from both sides, so x is equal to -4. These are the two numbers that make this statement true. If I plug in a -8, I would get an answer of 8. So that's what it's saying. If you plug in -8, it's going to work. If you plug in -4, it will also work. This last problem is very similar to this one. Do I need to slow down? Okay, last problem. They're telling us that f of x is equal to 2x squared minus 15x. And they want us to find all values of x if f of x is equal to -7. So we've got the situation where we're plugging in -7 for f of x is equal to 2x squared minus 15x. this has to be equal to 0. Okay, so in order for me to get this, solve it, it has to be equal to 0. So I want to add 7 to both sides of my equal sign. So I will get this equal to 0. So 2x squared minus 15x. I'm going to have to tack on that 7 at the end because it's not a like term with these other two. It doesn't have an x in it. Okay, once I get it like this, I want to see, can I factor anything out of that? In other words, 2 and negative 15 and 7, but they don't have anything in common. So I want to go straight to 2 times 7, 14. So I want something that multiplies to 14 but adds to my middle term of negative 15. So how about negative 14 times negative 1? That's 14, but negative 14 plus negative 1, negative 15. So those are my two numbers that go right here. Negative 14 and negative 1. If there's a number in front of the x squared, which this one does have a number in front of the x squared, I have to divide by it. So I'm dividing by 2 on both sides. Negative 14 divided by 2 is negative 7. So that's one of my things that I've got to consider. And then this doesn't reduce or doesn't, so we're good with that. So we've got a negative 7 and a negative 1/2. Remember that you can write that over a 1 so that you can get this to, if you kind of struggle with that part, but the number on the bottom goes in the front, minus 7. So 2x minus 1, and we know this is equal to 0. So we have completely factored it now, which we've been working on for several days. Now we're going to solve, several lessons we've been working on that. So now we're solving. So you look at it and you say, well, when is 1x minus 7 equal to 0? And when is 2x minus 1 equal to 0? Well, this one's easy. We would just add 7. So x, or 1x is equal to 7, which is the same thing as x is equal to 7. So one of my answers is x equals 7. The other answer is x equals, we'd have to add 1. So 2x is equal to 1. And we would divide by 2. And so x is equal to 1/2. Do you see any similarity to this number that we got for the answer right here and the original answer of negative 7? They're opposites of each other, right? So we really don't have to do, if you can recognize this, and you really don't have to do all the work. This is 1/2, and we started with negative 1/2. So it's always just going to be the opposite of what you got when you did this little cross part every single time. It's going to be the opposite of what we plugged in. And that is 4.8. And we will be reviewing for our chapter 4 test next class. I know that I think you've got another week to take it. It's not due till the next week, but that's where we're going to be in class to stay up to date.